Okay, so from my end, I think I'm audible. Just you guys just confirm me whether I'm audible or not. Okay. If I'm audible and visible, then I'll start the stream. Okay. I think my face is not that lit up. If it's this angle, then it will be lit up. But it's okay. It's okay with you guys, I think. Then just quickly tell me if I'm audible or not. Okay. So I'll start with it. Hello, hello, hello. I'm audible, right, Aditya? Perfectly audible. Perfectly audible. Okay. I think my the quality of my streaming has also improved, right? Voice is a little low. Yeah. I'll just tell you guys that just put the volume a little bit higher because I have used a noise compression so that like the voice is a little low, but it's more crystal clear, right? Is it much more clearer than I used to stream? Okay, I think it's clearer. You know? Yeah. Okay, so let's. So how many of you attempted today's AtCoder contest? Just tell me, okay? Okay, so this is the. Just a minute, huh? I'll just fix the whole setup because I'm streaming after a very long time, so I have to set it up, right? So I have to set it up properly. Okay, now the setup is perfect. Okay, so I'll do one thing. I'll just share this link on Discord and then I'll start with the stream. Okay. I wasn't even I wasn't even had idea of this contest. I gave it after seeing a live schedule. Yeah, even I don't give this kind of contest, but today I felt that yeah I should give it a try. So that's it. I did it. Okay, nothing much about it. I just gave it, and this was a good contest. How many questions did you guys do? Like it's good that people like haven't seen much of Indian coders doing at coder, so it's good that Indian people are doing at coder. That's nice. Yeah, I will give the hacker cup. I think the hacker cup is from 8, right? I don't know. So I'll just end the stream like real quick if the hacker cup is. I don't know. Just let me check. Okay, hacker cup 2024. But I won't be explaining like too much of the contest. I mean too much of the questions. So it won't be a like that big issue. I think I can end it. So yeah, it's starting from 10:30. Okay, I have a lot of time. I have a lot of time left. No, okay. So let's go with today's AtCoder solutions. Okay. So I think it will be better. No, it's okay. So the first question, let me put it over here. The first question is Takash, Takahashi Sand 2. Okay. The problem is very simple. It's very simple. So I'll just go with the problem statement real quick. KEYENCE has a culture of addressing everyone with the suffix "san", okay, regardless of roles, age, or position. You're given a string consisting of lowercase English letters. If S ends with "san", print yes, otherwise no. This was a very simple thing. Like, you know how to do it. So there are a few conditions that we have to check. So first of all, I'm having like it can be a yes, okay, or it can be a no, right? Now, anyways, how many questions do you guys do? I think the chat is not lagging that much. Okay. So one thing is a yes and the other is a no. Okay. Now we have to find like when will it be yes and when it will be no. So it will be a no, direct no if like if it can't have. Okay, two questions. Good. Two. That's good. I have done uh, four questions and the fifth one I have done a little bit. Okay. So the fifth one almost 70% of the test cases passes, and I think it was an overflow thing, so I didn't use the modulos. So I'll explain till E only. Okay, till the five questions only. Okay. So whenever you're having like it can be a yes or a no. So the suffix can be san, right? Third, 12 accepted, rest all wrong. Okay. Yeah, I'll explain it. Okay. You don't need to worry much about it. So if the length of the string is lesser than 3, it means that it can't have a suffix only, right? Of san, right? In that case, it's a direct no. And if it is greater than equal to 3, then we have to find out the last three elements. The last three elements are S, A, and N. Then it's a yes. Okay, a very simple code. So I'll just go through the code real quick. This was Takashi San. This is very simple. I'm taking the length. If the length is greater than equal to 3 and the last three letters are S, A, and N, then we can say it's a yes. Otherwise, we can directly say that it's a no. Okay, clear? This I think this is clear with you guys, right? If it's clear with you guys, just write in the comments B. Okay, so I'll just move on to the next question. B. Okay, Rohit wrote C directly. Okay, Rohit, just wait a little bit. Okay, so I'll explain till E. Okay, you don't need to worry. I will explain C, D, E, L. I'll explain everything. Okay, so now first let's focus on B. Okay, so Keynes has a culture. So the question, unvarnished report. Okay, so Keynes has a culture of reporting things as they are, whether good or bad. So we want to check whether the reported content is exactly the same as the original text or not. Okay, so it is basically you're given two strings, so you have to find out the first position where these two strings differ. Okay, and if it doesn't differ, so return 0 because it doesn't differ, right? So this is also a very simple thing, a very simple question. But since like for the sake of understanding, I think it will better like if I explain you with the whole logic first. So let's say you have a string S and you have a string T. Okay, now what was it given that if both of them are same? Okay, so first of all let's think about that the length of S and the length of T are same. So if they are same, that means the answer can be ranging from 0 to n, right? 0 to n, right? So for all the elements from 1 to n, okay, from 1 to n, you can check if all of them are same or not. And if at any position you find that it is not same, so you can return it. And if all of them are same, just return 0, right? This is very clear. This is the first condition. This is the case 1. Okay, the case 1 tells us that the length of S and T both are same. Okay, so that is a very simple thing. But what if the length of S and T are not same? So if the length of both the S and T are not same, so in that case what you have to do is you have to like focus on the fact that you have to go till the minimum of both its length. Okay, length of S. Okay, so it is S only. Okay, and length of T. Okay, and it is also a similar thing only. Like you go to the minimum of length of S and length of T. So that is almost like this. And if you find that any position differs, so you can directly say it to be that position. But otherwise, in this case we were returning, otherwise we were returning 0. But in this case we won't be returning 0. Instead we are going to return minimum of this okay, I mean minimum of this plus 1, sorry, plus 1, because that minimum length is already equal, right? So that minimum length till S and T, like both are equal till that length. So just after that the thing differs, so that is minimum of this comma this plus 1. So if you look at the solution is very simple. If n is equal to m, then check for 0 to n, and if any of them differs, so you can make f is equal to I plus 1, otherwise f remains 0, you print f. And if it's the otherwise thing, so we are going to again check for the same thing, and if anything differs, then f is equal to I plus 1, otherwise f is equal to minimum of n comma m plus 1. What is n comma m? N comma m is the length of s1 and s2 respectively, right? So is this clear with you guys? Is this clear with you guys? If this is clear with you guys, just write it in the write in the live chat C. Okay, so I'll move on to C. Okay, anyways, people who are new to this channel, I'll just request you that please do subscribe my channel. So that's it, nothing much. Okay, and like this video so that it motivates me to make more videos. Okay, so everyone is saying C. Okay, let's go on to C. Okay, separated lunch. Okay, as I think I have to do one thing. I have to make this a little bit smaller. Okay, so that not this small though, just for now, just while I explain the question, I'll just make it smaller so that you guys can read the whole question properly. Okay, so just first look at the question. uh, Problem statement: as KEYENCE headquarters have more workers, they decided to divide the departments in the headquarters into two groups and staggers their lunch breaks. KEYENCE headquarters have n departments, and the number of people in the I department. Meta hacker cup. Yeah. Okay. Yeah, I know. So KEYENCE headquarters have n departments, and the number of people in the I department from 1 to n is k of I. Okay. When assigned each department to group A or group B, having each group take lunch breaks at the same time and ensuring that the lunch. So this is not much important. Okay, this is not much important. So I'll tell you, just basically I'll tell you the gist of the thing. Okay, so you're given n and you're given k1 till k of n, and you have to divide this k1 to k of n into two groups such that the the maximum of the sum of group A and group B is minimized. Do you get it? So I'll just give you an example. So let's copy this. Okay, so you'll get it the better way. Now I think I will just expand the whole thing. Okay, over here I'll just paste it down. Okay, now see. So what you can do is you can group this, and this. Let's say this. Okay, this in group 1 or group A rather, and you can group this in group 2 or group B. Okay, so these two makes it 15 and these makes it 17, right? So what is the maximum among 15 and 17? It is 17, right? So doing this, you can group like any elements into any group, either A or B, right? And you have to like find the maximum of group A comma group B, and you have to minimize it. So let's say if this 5, it was not in group 2, rather it was in group 1. So this 17 would have been plus 5, right? So 17 plus 5, and this 15 would have been 10. So obviously 17 plus 5, that is 22. It would have been the answer, but the answer is 17 because we can reduce it. So we have to like make the minimum, we have to find the minimum of the maximum of the two groups. Okay, now how to do this? It is a simple approach of bit masking. Okay, so how many of you know about bit masking? If you know about bit masking, just write in the live chat BM. Okay, just write in the live chat BM. Anyways, people new in this channel, I'll just request you to subscribe my channel and like this video. Okay, nope. Okay, so I'll explain you the whole concept of bit masking in such a way using this question that you will get it. Okay, let's see. Now first of all, you have to understand that why are we using bit masking. Okay, we are using bit masking because if you look at the constant of n, the maximum value of n was 20, right? So let's say if I am having like every element, so in spite of putting it into group A and group B, let's think it this way, that I'm considering one element and whether I'm putting that element into group A or not. Because if it's not group A, then it's group B, right? So it's either I put it or I don't put it. So how many total permutations are possible? Can someone tell me how many total permutations are possible? Can someone tell me how many total? Do you guys have any idea like how many permutations are possible for this? Okay, so I'll just tell you, okay? Because I'm just assuming that you guys don't have an idea about this. So let's say there are n elements, okay? There are n elements. So you can put this element in either group A or group B, right? So let's say for group A, we are going to name it 0, 2 to the power n, exactly. And for group B, we are going to make it 1. So every position can be a 2. So how many total permutations are there? 2 to the power n, right? Now think about this. So I have to find all the permutations. How can I find all the permutations? If I make the binary from 0 to 2 to the power n minus 1 and have its binary representation with n digits, I'll have all the permutations. Is it clear? Because for 0, all of them will be 0. For 1, the last one will be 1. For 2, the previous one will be 1. For 3, these two will be 1. So basically for all the permutations, I can go from 0 to 2 to the power 2n minus 1. And similarly corresponding to it, we are going to find out. So on which group we are going to place it. Okay. Is this part clear with you guys? If this part is clear with you guys, just write in the live chat clear. Okay. Just write it clear. Normal. If this part is clear, I think it's like you guys will get it. It's good to see that people are doing AtCoder contest. Like that's good. Not clear? Okay. See, in these places, you can either put 0 or 1, right? So if you go from 0 to 2 to the power n minus 1, what is 2 to the power, 2 to the power n minus 1? It is n number of ones, right? 2 to the power n is 1, 0, 0, 0. How many zeros are there? N zeros. And if I make minus 1, so all of the zeros becomes 1, right? So there are 2 to the power n minus 1 is n number of ones. And 0 is basically n number of zeros. So anything, any binary between them are going to tell us all the permutations. Okay, because we have to check like this key. In this position put 0 or 1, in this position put 0 or 1, in this position put 0 or 1. So we can't like have a loop, right? We can't have a loop because the loop will have a different kind of condition. We can do it like for this I'm putting 0 and then checking for all of them, and this I'm putting 0 and then checking for all of them, right? So in spite of doing that, if you look at the binary representations, it is similar. Okay, so let's say if it is 0 0, then 0 1, then 1 0, and then 1 1. So let's say there were two people. Okay, I mean there were two groups. What was the question though? There were, what does K denote? K is the n department. So let's say there are two departments. Okay, so this means I'm putting both the department in group A. Okay, this means I'm putting this department in group A and this department in group B. And this means I'm putting this department in group B and this department in group A. And this means I'm putting both the departments in group B. So these are the only permutations that are possible, right? So basically, if you look at this, so these are the representation, the binary representations of numbers from 0 till 2 squared minus 1. Now is it clear? Because we are just more concerned about the number of permutations, like all the permutations. Why is it so? Because n is 20, right? It can be 20. So 2 to the power 20 is not that big number that you it will give you a TLE. Okay. Now write if it's clear or not. Clear. Okay. Now let's get into the code, because I think now if you look at the code, you'll understand what I've done. Okay. So first of all, I'm taking the sum. That is, I'm taking the sum of all the elements of AR of I. Okay. I mean the array. After that, I'm making answer is equal to sum. Okay. Because initially it may happen that all of the elements are going to one group only. So in that case, the answer is going to be sum, right? Now I'm going from 0 to 2 to the power n minus 1. Or you could have also written it as lesser than this. This also works the same way. Okay. Now I'm taking j is equal to 0. J is actually the pointer for the, what to say, the pointer for the array. Okay, it's the pointer for the array. Then I'm taking a temporary variable of I, because I don't want to overwrite I, because I have to convert that element into binary, right? But I don't want to overwrite I. So I'm taking it in temp, and then I'm converting this temp into its binary form. You know that d is equal to temp mod 2 and temp I is equal to 2. Now if d is 1, in that case I'm adding AR of j to s, otherwise I'm not adding it. Okay, because let's say if I'm not adding it, it means it is in group B, and if I'm adding it, it means in group A. Okay, so what is in group A? It is S, and what is in group B? It is sum minus S, because the sum of all of them is sum, so sum minus S, right? So is it clear? So I'll just make the minimum of maximum, right? So is it clear for you guys? So if it is clear for you guys, just spam in the live chat D. Okay, if it's clear, if it's clear. Otherwise, like, you can write not clear. Can one group have only one element into it? Yeah, it's not a big issue. It can have only one element into it. It was not given in the question that uh, like you have to have one element. That was not given in the question. Okay, so you can have it. But anyways, it's a better approach that it doesn't have it, because like you don't know actually. It may happen, it may not happen. Right. Any tips on how to debug when we get a wrong answer? I was totally stuck with my approach and couldn't figure it out. See, this approach, this was a bit masking thing. How I made it out is like, you may think that you have to do some, like, what to say, some sorting and then whatever it is. But since I'm having n as 20, so it means that I can go till 2 to the power 20, right? Whenever there's a 20, it means 2 to the power 20. So if it's a 2 to the power something, then it means that it's a question of bit masking, right? So from the constants you can get it, like what is the question all about. Anyways, should I go to D? If I go to D, if I should go to D, just write in the live chat D. Okay. People who are new to my channel, just subscribe my channel and like this video. Okay. I will not apply the memorization approach in the C. The question happens to be a variation of subset some target. Yeah, I'll go to D. Subset some target. I think I don't remember whether I have come across this thing or not. No. I think you can't do it. Okay, can't do it. I'll tell you why. Because like if you're going for subset sum target, so you have to go from sum by to till sum, right? And for the first condition that it satisfies, you have to do it. But if you are going like, if you're going to do like that, so it's kind of okay. But since you have this condition of 20, so why not directly use bit masking? Because that was not that question, like you have to imply that much of brain into it. It was like just experimenting whether you know bit masking or not, nothing more than that. Okay, so let's go to D. Laser marking. This was an interesting question. This was a very interesting question. Anyways, first thing that I will like, so first I will just minimize this. Okay, put this in the background, put this above it. Okay, so there is a printing machine that prints the line segments on the xy plane by emitting a laser. Okay, at the start of the printing, the laser position is at coordinate 0, 0. That means it's the origin. So when printing a line segment, the procedure below is followed. First, move the laser pointer to one of the endpoints of the line segment. One may start drawing from either endpoints. Okay, so what does it mean? Like, let's say I'm having 2 points. Okay, 2, 0, I think this was there in the question, the first test case I think, and there's 0, 0. So you can either start drawing the line from 0, 0 to 2, 0, or the vice versa. You can draw from 2, 0 to this. You got TLE. You applied which approach? Like Rohit, are you talking about D? You're talking about D, right, Rohit? Anyways, just look into the question. Okay, if you're talking about D, then just look into the question. If you're talking about C, no, it's not a TLE. Okay. Then move the laser pointer in a straight line from the current endpoint to the other endpoint while emitting the laser. So basically, you can either emit the laser, or you can like just move the laser. Okay. So if you're moving the laser, it is having a speed of s unit per second. And if you're like drawing with the laser, so it will have t units per second. Okay. So what you can do is you can let's say you have got a few points. Okay, you have got a few points L1, R1, or let's say not L1, R1. So I'll just write it as X1, Y1, or let's say X11, Y11, X12, Y12. Okay, and then you have till X N1, Y N1, X N2. Sorry, it's N2 only. Okay, what the heck is happening with me? So it's X N2 and Y N2. Okay, so for like all of these, you can have like what to say. You can start from this position. You can start from any position of any element and go on till any position of any other element, right? So this is what basically the question tells us, and you have to find the minimum. What was it? You have to find the minimum number of seconds required to complete the printing of all the segments when we operate the printing machine optimally. So we have to finally like find the minimum number of seconds that we need to print all the lines, all the line segments rather. Now the fact is like how we are going to do it. So what do you guys think? Like how we are going to do it? Any idea? Just look at the constraints first. Okay. Now tell me how we are going to do it. The previous one was 20 and this is 6. There you will be needing two approaches. If anyone can tell me just one approach, so I'll know that you're getting it. Okay. Just give a random guess only. Okay. Just give a random guess. Just give a random guess and I'll just tell you whether that approach is needed or not. Okay. Then it's group B, right? DP. DP, why would you need DP? Because DP is needed when you're going for big O n squared or big O n cubed, right? Even for big O n to the power 4. But this is like 6, right? So don't you think from the constraints that you're going to need something like recursion? Don't you think that is kind of recursion? Because recursion supports this 1 to 6 thing is supported by recursion. So actually not from 1 to 6, even 1 to 7 or 1 to 8 also recursion supports. Okay. Recursion supports when n is equal to 8. Even till 8 recursion supports. Because recursion is basically nothing but, first just let me remove this. Recursion is basically nothing but a big O of n factorial. Backtrack or recursive, exactly. Backtracking is needed. I'm just explaining recursion, but actually it's backtracking only. More like backtracking only. Okay. You're going to need, okay, so now I'm just revealing what you're going to need. You're going to need backtracking. Okay. Backtracking you're going to need for finding all the permutations. Why do we need to find all the permutations? Because we can start from any position and go on till any position, right? We can either start from one position and go on to the other position. Like it doesn't matter from, like we can start from A6, because over here in this case, if you look, they started from 00 to 02. That is the second line segment. So they went to second, first, and then third. That is, you have to find all the permutations for 1, 2, 3. And this 2, 1, 3 is a permutation of 1, 2, 3, right? So if you find all the permutations of 1, 2, 3, and then you're going to do a bit masking. Now what the bit masking is all about? The bit masking is all about whether you're going from this point to this point or this point to this point. You get it? So one is this, other is bit masking. People who like bit masking, I think this was a very good contest for them. This was like a contest completely based on bit masking, I think, like recursive bit masking stuff. And it's nice to see that they're making such brilliant contests. Okay, so AtCoder, like big shout out to AtCoder, and big shout out to KEYENCE. Okay, don't know what it is, but anyways, big shout out. Like they made a very nice contest for us. Now the bit masking tells us, like if it's a 0, the same it's similar to the previous one. Okay, so if you're looking at the pre-recorded version of the video, so I'll just recommend you just go back to the previous question and understand what bit masking is all about and why we have used bit masking in that. So now you'll just understand this better. Okay, so bit masking, so you can either have 0 or 1. So whenever you're having 0, let's say if you're having 0 or 1, so if you're having 1, you can take the first two elements first and then the next two elements, right? Because it was given that you have to go from A1 comma B1 to C1 comma D1, or from C1 comma D1 to A1 comma B1. So you can have anything, right? You can either go from this point to this point or this point to this point. So basically there are two options that you can make. You can either choose the first point first or the second point first. So if you're going to choose the second point first, make it 0, and if you're going to choose the first point first, make it 1. Right? Simple. That is bit masking. And then backtracking for permutation. So using the backtracking for permutation, we are going to find out all the permutations for 1, 2 till n. Okay, and inside of this we are going to find for all the bit masking, and then we are going to compute, and whichever is going to give us the minimum solution, we are going to take it. Like, do you get the gist of the whole solution? If you get the gist of the whole solution, just write in the live chat yes. Okay, just write in the live chat yes. Anyways, people who are new to this channel, I just tell you guys that please do subscribe my channel and like the video. Okay, just write yes. Yes. Okay, now look at the code. Okay, now look at the code. The code is a little bit lengthy, so first let me tell you, this void permutation is going to store the permutations for all the permutations. Okay, you can find this whole thing, I think you will find it in GFG. Okay, you can find it in GFG. So in GFG, just go and search all permutations for, all permutations for 1 to n. Okay, and it is a kind of simplified version of next permutation question. Okay, which is there in lead code. Okay, so I'm not explaining this because this is very like a basic normal like recursive approach, so I'm not explaining this. You guys can like look for it and directly get the explanation for this. So I'm just going directly to the code. Okay, so nst, then I'm taking AR of n4. Okay, so I'm taking the inputs. So either the points are going to be this or the points are going to be this, right? That is what was given in the question. Now I'm going to make just a permutation. Okay, the basic permutation, that is 1 2 3 4 5. But since we are having a zero based indexing, so we are not going to focus on 1 2 3 4 5. We are going to focus on 0 1 2 3 4, right? So I'm going to make br of I equal to I, and we just make all the permutations permute br, and answer is, I'm taking a very big value for answer because we have to find the minimum element, right? You can even consider it as infinity. Okay, so this is basically infinity. And then what is the number of permutations? It is 1 2 to the power n, right? Just like the previous question. So you can write 2 to the power n as this. Okay, this is normally the left shift. Okay, so you're going from 0 to 2 to the power n I plus plus, and initially L and R were at 0 0, right? It was given in the question. If you look at the question, initially our pointer is at 0 0. Okay, so now we are having this k. So again, temp is equal to I, the same thing, nothing like much complex. So while k is less than n, so there's a little bit difference. In the previous question, we were not doing k less than n. Okay, we were more like focusing on temp greater than 0, right? But over here we are more focused on k less than n because we have to consider all the elements. Because in the previous question we were not focusing on calculating all the elements, we are just focusing on the elements which were having 1. We didn't need the 0 because we are pre-calculating the sum, right? But over here there is nothing such like that, so we are going to make it k less than n, while k less than n, and then we are also having a k plus plus at the end. So basically we are going from k is equal to 0 till n, right? I'm just using a while loop. You can also use a for loop. Okay, it doesn't matter. So the same thing, d is equal to temp mod 2. If d, then abcd. Okay, abcd is in the format of 0 1 2 3. Otherwise it is going to be in the format of 2 3 0 1. That is the reverse thing. Okay, as I told you. And then you have to find the, like, whatever it is, like, you know, the formula for the distance between 2 points. It is the square root of power of x2 minus x1 whole squared and y2 minus y1 whole squared. So that's it, the same thing, and divide by the speed, because this was the speed that was given in the question, s and t respectively. So we are just applying that to the value. Okay, and then we are just improving, like we are making L is equal to C, because now the laser is pointing at C comma D, right? So now it is pointing at C comma D, and this is 10 by 2, that is this thing, that is for the binary thing. Okay, and then at the last we make answer comma back. Now it was also given in the question, that we have to make it that only the absolute or relative error from the true value should not exceed 10 to the minus 6. Okay, that is 6 points after the decimal place. So I made it 8 points after the decimal place, so that it doesn't exceed that relative error. Okay, just for our safety, you can also go with 7 also. Okay, you can also go with 7, doesn't matter, but I made it 8 so that it's better. The more it is better, right? So is this clear with you guys? If this is clear with you guys, just write in the live chat. This was D, right? So just write in the live chat E. I don't know why the heck this is getting a little bit laggy. Can we solve by using graph? Okay, see see this case. Okay, so it tells us that this is like failing. Why is it failing? Because there is a relative error, right? So if you look at it, 44317476, the last element is rounded off, right? So it's better to do for 8 only. You can also go for 7, it doesn't matter. Now if I go for some other, like if I make it 10, so I'll just also run it for this. So now you'll just look at it, like it is more precise. The more decimal points I put in it, it is more precise. Now see, it is more precise, right? Okay, no, it didn't come. I don't know why it is taking so much of time. I think there's a lag from my end only. See, now you can see that it's coming till this position, 8 7, right? So that's it, nothing much to worry about. Okay, so let's go on to E. Okay, so can we solve it by using graph? See, I haven't given it a thing. Okay, so I haven't given it a thought. You may solve it through graph also. I don't know. Okay, I won't risk it. But I think it's like better to solve it the way I have solved it, because you were having 6. So just think that maybe it can't be solved using graph, because otherwise they could have given like a better constant, right? I mean a bigger constant, but they made it 6. So I think that this is a better approach. Okay, sensor optimization dilemma, part 2. The manufacturing of a certain product requires n process numbered from 1 to n. For each process I, there are two types of machines, SI and TI, available for purchase to handle it. Machine S of I can process AI products per day per unit and cost PI yen per unit, and machine T of I can process BI products per day per unit and cost Q of I per unit. Okay. Suppose that process I can handle WI products per day as a result of introducing machines. Here we define the production capacity as a minimum of W, that is minimum of like all of them, okay, of all of the W's. So what you have to do is, like, let's say you have a budget of X yen, so you have to divide this X yen among all the processes, and you can buy like one one, like let's say you can buy some number of machine S1 SI and some number of machine T of I, and based on that you can like perform some operations, and like you have to find out how many products you're making. Okay, so basically you have to make the minimum of products that you're making, maximize it. Okay, similar to like the maximize minimum, right? You have to maximize the minimum. Okay, so I think it will be better if I go with some example. Okay, so for this example 253613, this thing. So in the first case, if you're using 2 units of machine S1, right, that means 5. So how many yens do you need? 5 into 2, that is 10. Okay. This allows processing 4 products because you're having 2 units. So 2 into 2, 4, right? For this, he's using S2, that is the second machine. Okay. I mean not the second machine, the first machine only. Okay. So he's making 1 binary search. Exactly. It's binary search. So it's 1, 1. Bored to death. How many questions did you do, by the way, bro? And then for process testing, so that is basically the, like, he has done it, and the sum you can see that's 10 plus 1 plus 3 plus 8. You have done till D. Okay. Like how many test cases were passing for E though? Like from your end, or like did you like go on to submit E, or you didn't submit E only? So if you like sum these up, first 3. Okay, so I'll just show you one thing before like explaining the thing. Okay, so you can have 10, 1, 3 and 8. So if you sum up them, so it becomes 22. That is our budget. Okay, and what is the maximum of them? 4, 1, 3 and 4. So maximum is 4. The output is 4, right? So is it clear? Is the question clear with you guys? If the question is clear with you guys, then I'll just move on to explain. I am just assuming that it's clear with you guys only, okay? Because this is not a big deal to understand the question. The big deal is to solve the questions. Okay, let's take this first example. So now, as board to that told us that we are going to do binary search only. Okay, so how we are going to perform the binary search? So let's say our budget is 22 and it is 3, right? So what do you think can be the maximum for this? Okay, what do you think that can be the maximum for this? You can have 0 also, right? The minimum can be 0 and the maximum can be 10 to the power 9, right? Because it is well within our limit. That is, let's say if I'm having 10 to the power 7, it was given in the constants, and I look at the constants once. Okay, so it was given that it's 10 to the power 7 only, right? Now since it is 10 to the power 7 only, so this A of I and B of I, we don't know about 100, but since A of I and B of I is the, like, we are dividing it with A of I and B of I, so we are going to consider it as 1 because we have to maximize it at this moment. and n is we have to multiply. Okay, so that is basically 10 to the power 7 into 100, that is 10 to the power 9. So 10 to the power 9 plus 1, I think that's a safe upper limit. Okay, so you can introduce this as L and this as R and perform a binary search in it and check for every specific element, I mean every specific answer, whether it is possible to have that value or not. Okay, because we have to we have to find the maximum of the minimum, right? Or like the minimum of the maximum, sorry, the minimum of the maximum, right? Now since we have to no, we have to find the maximum of the minimum. Okay, so we have to find the maximum of the minimum. So in that case, if we like get that this is the minimum and we can attend this for every value, so we can after all, like after we have like checked it, so we have to just check whether the budget of doing that. Okay, let's say we are having mid. Okay, so we have to find that if I want to make all of them make mid, okay, all of them make mid, what is the total budget that I'm getting? If the budget is well within our limit, so that can be a possible answer. If the budget is not within our limit, so we have to reduce the answer, right? So if the budget is within our limit, L is equal to mid plus 1. Otherwise, L is equal to mid minus 1, right? I hope this is clear with you guys. Now there is a little bit of like confusion that you may understand, like if you go to the clarification part. Okay, both machines Si and T of I can be used for the process of I. What does this mean? If you purchase both machines S of I and T of I, the number of items that can be processed in process I will be the sum of the items processed by both the machines. So it is giving you the opportunity to use both the machines. So it doesn't mean that we have to use the machine which is more efficient, right? It may happen that we can use a few number of times the non-efficient machine and a few number of times the efficient machine, right? Now we have to think about it. How many times we are going to use which machine? Okay, so that is the part where most of the test cases may fail. Okay, now let's say I'm using 1 unit of this and then I have to find out how many unit of this I am going to use. Then I'm going to use 2 units of this and find out how many units of this I'm going to use. And based on that, we have to like find the whole thing. Okay, we have to find the whole thing. Now, if you are looking, now I can provide you a solution which will pass almost 70% of the test cases. But there will be a few test cases which won't pass for it. Okay. That is, let me tell you. So let's get into this. Okay. So basically, I'm taking it in the form of APBQ. Okay. The normal same thing. L is equal to this, R is equal to this, answer equal to this, while L is less than equal to this, mid equal to this. Then I'm going to find the cost. And then for everything, I'm going to find the cost. Okay. So I am having some amount of B and some amount of C, right? Initially. Now what I can use is I can increment the number of C's and decrement the number of B's. I mean, it's not CB, right? It's AB, sorry. I'm having some amount of A and some amount of B. Okay. Now what I can do is I can decrease the number of A's one by one and check how many B's I will be needing to fill up that. Right. I can do that. But in this code, I haven't done it. So that's the reason, because I was just focusing on like doing the code as fast as possible. So I haven't done it yet. But you can do it. So what I have done is I'm taking D is equal to mid of this, C is equal to this. And first of all, I am checking, like I am placing all of them as C. Okay, all of them as C. And then I'm checking like how many are not there. So I'll just explain you what I'm doing. So A is equal to mid by AR of I of 0. Okay, that is how many elements, how many W that we have, and how many operations that we need to perform. I mean, how many machines that we need to purchase for that. That is A. And if I multiply that with the cost of that machine, so I get what is the cost of that machine, right? Now we are going to even find that if mid mod AR of I, this is this, this is this. Like, this is normal bullshit. Okay, you don't have to worry much about it. but something that we can modify it. Okay, we can modify it somehow. How can we modify it? So let's say after implementing this, what I have done is, what first let me tell you what I have done. Okay, what I have done is, after implementing it, it may happen that after dividing it, something is there in the remainder. Okay, some of the other elements that we haven't considered yet. So in that case, I'm just checking whether in that position I'm going to purchase the first machine or the second machine. Okay, which is going to give me a better option. And for the second case also, I'm doing the same thing. But we have to have some other test cases also, right? We have to it doesn't mean that just for the remaining case we have to use it. We can even go on decreasing. Okay, we can even go on decreasing this and check by how much do we need to increment b. Okay, and then based on that we have to find the minimum. Okay, we have to find the minimum, and if cost is greater than x, we can break it down. So this is normal thing, because I just wanted to remove the unnecessary conditions. Now if cost is lesser than equal to x, answer is equal to mid, l equal to mid plus 1, r is equal to mid. So technically this thing satisfies the conditions that are given in the test case, but there will be a lot of test cases that won't be satisfying this condition. What are those test cases? I think my device is lagging because of this, because of compiling them. It's better that I'll compile them later on. Okay, but yeah, it passes for all the test cases. Okay, you don't have to worry much about it. So this is how we are going to do it. Okay, so it's a mild request that I couldn't do it in the stipulated amount of time, but you guys should try to attempt that. What I told you, that is, I'm decreasing this from A and I'm increasing something to B. Okay, I'm increasing something to B, that is not 3, yeah, 3. Okay, so for every specific element you have to find the value of x. Okay, you have to find the value of x, that is, after you have done it, so you're going to remove one a one machine, one from machine, you have to remove one machine of first type, and then check how many machine of second type you need to add to it to make it better. Okay, so based on that you have to make the calculations. Okay, very simple thing, you can do it, I think. So if you guys till now, if it is clear with you guys, so just let me know. Okay, just write in the live chat clear, because I won't be explaining anything else. This was the last question that I was explaining. Okay, is it clear with you guys? Just write it in the live chat quickly, because I'll just end the video also. Okay. So I can show you understandings. I just show you my submissions. Okay, I'll show you my submissions. See over here, if you look, so what I did, it solved 4 of the sample test cases and 64 of the this test cases, and 34 went wrong. Okay, so whatever this 34 were wrong, that was the condition that I told you guys. Okay, nothing more than that. You don't need to worry much about it. Okay, this 34 wrong, I think you can handle it by yourself. It's not a big issue, right? Because if you look at a question and you see that 64 are right and 34 are wrong, so you know that just a minor change. Okay, so I'm just considering that you guys have understood the whole thing. Okay, because even I have to end the live chat. I mean, not the live chat, the live stream. Okay. So I'm just assuming that everything is clear with you guys. So I'll just end it. Okay, thank you guys for joining. So I'll just end it. Okay, thank you, bye. Radhe Radhe.